Hi everyone, my name is David and I work in the personalization team at Rightmove. So just to give you a little bit of context, personalization team does own every single piece of software and works with every piece of software that is behind the registration of a user on our website. Today I'm going to talk about a project that I've been working with for quite a long time, which is Property Alerts, and how did we transform into microservices and how the journey was during this period. So, which one of you knows what's a property alert? Nice, those guys. Right, so just a quick idea. So a property alert is, in our world, is an email that we send to our users with the relevant properties that match each user's searches in our website. So in order to save a search, a user just logs into our website, does search for a location plus the radius that he wants to get properties from. He does set up his budgets, his number of bedrooms, the type of house that he wants to see, and so on. And then, by changing the frequency of his alerting, you can just click on this create alert, and that's how he's going to start receiving the property alerts. Okay. So my next slide is a screenshot of what a property alert looks like. So as you can see, we are sending to David 2 beautiful properties that actually match his search that he saved previously. So what was the problem that we were tackling here? So we had a legacy application called Property Alerts, which was causing an incredible load on our database. So the old Property Alerts, just to give you a rough context, so we do own 3.5 million saved searches. So what the old legacy application was doing was pretty much load every single one of them and try to get all the properties that were relevant to each one of these searches, and then send them to the email server so that they could be processed. This was happening pretty much every 10-15 minutes. So it was an incredible stress to our database. It needed to change. So another problem was no monitoring. So this application was pretty much by itself, and it was doing pretty much whatever you wanted. The property matching was also not 100% effective, because it was being done at runtime. So the effort was massive, and it was causing some delays in some alerts. We were also handling the search engine that was doing the matching in between properties and safe search was also expiring, so we need to get rid of it. So what was the solution that we approached? Microservices. So why microservices? Because we wanted to change the pace how we were developing our applications. So we wanted to make changes in a more agile way. We wanted to deliver features even quicker. We want to get rid of shared core dependencies. Pretty much we wanted to be in control of our app. So what we decided was, let's split this application in two. Let's have the property matching logic in one microservice and the alerting logic in another microservice. So the tech stack is quite big and quite interesting. So in-house we developed pretty much everything in Java 8 alongside with Spring Boot. We also use the ELK stack. So ELK stands for Elasticsearch, Logstash, and Kibana. So Elasticsearch is being used to store every user saved search, and its Logstash obviously is loading all the logs from each application box into Kibana so that we can see very beautiful monitors. We are also using a NoSQL database called Couchbase. So Couchbase is an extremely quick NoSQL database which allows us to get information so quickly. It's really great. As a messaging system, we are using Kafka. We are also using Docker for integration tests, and we are also using Jenkins to build our pipelines. So talking a little bit about the architecture, this is what looked like pretty much. So we have Property Alerts, which was a massive application that was sit on top of our Oracle database, which was doing all that process that I was talking about in the very beginning, and then spitting out all the combination between safe searches and properties into our email server, and then the email server was responsible to deliver the email into each user. The architecture nowadays looks pretty much more like this. So in the middle, we can see our brand new two microservices. So we have the property matching. So all the property matching sits in there, and all the alerting logic sits in the alerting service. There were already 3 existing microservices deployed, so they were already running, which were the safe search service, the location, and the property listing service. So these 3 sit on top of Oracle database. So whenever a safe search does get updated or does get created, when a user creates a safe search, the property matching service would pick that update or that creation up and would inject it into Elasticsearch. So afterwards, the next step would be to pick up property updates, property listing updates. So whenever a property does get into the market, our property matching service would receive that notification and would perform a very special operation in Elasticsearch, which is called percolation. So percolation can be defined as a reverse query. So what normally we do is pretty much perform queries in order to get property listings back. The percolation does things on the reverse. So we pretty much use a property and we try to understand which safe search do match this property. And whenever one of these matches is found, we store the property matching service is going to store in its own Couchbase bucket. Meanwhile, we have the alerting service, which has its own embedded scheduler, which kicks off from time to time and retrieves the user's frequency from his own Couchbase bucket, and then retrieves all the property matches from the property matching service, and then sends the same information that Property Alert was doing before to our email service. In order to get all the properties updates into our microservice, we were using Kafka and our Kafka topics to then process each updates individually. So what can be the future plans for this alternative for our microservices? So we feel that the scheduler could also be extracted to its own microservice. So this will allow us to have much more control in a per site basis. So what happens right now is if we are getting, for example, too many Kafka lags, it is ideal just to stop the scheduler, let our applications catch up, and then we restart the scheduler straight away. So by splitting the scheduler into its own microservice, it would allow us to stop in a per site basis, so we would have much more control individually. What is in the plan on the company and the prod dev is that in the near future we would have our microservice Dockerized. So this will allow us to deploy our apps much easier. We spin up instances in a much more comfortable way, and yeah. So what do we feel they were the wins for this approach, for this refactor? So we transformed the code in a much simpler and simplified way. So we took back ownership of the application. So we know what's happening right now, and we've built new dashboards. I think that wasn't existing anymore, and it's really important with these architectures. This is pretty much a Kibana dashboard, a print screen of a Kibana dashboard. So it's just to give us some example of what's happening. So we do have our error logs, now we have our app logs. We do have the counting of emails that we send per day and so on. So if anything happens, if some spike happens, we can take action straight away, and just by looking at these dashboards. We also made the whole property alert logic loose coupled. So it's not depending on shared core dependencies anymore. We made it scalable. So a good example of this, how scalable it was, is that at some point we understood that 2 instances were enough to handle the whole volume of the alerting, all the alerts, sorry, and we figured out that having 3 instances would split up the load in a much more elegant way. So we did this with a pretty much click of the button. The deployment became much easier, and I also have a screenshot of our Jenkins pipeline. So I don't know if you guys on the back can see, but each one of these boxes represents a stage of the deployment. But what I can tell you from here is that it takes around 25 minutes from dev up to prod. So it's whenever we want to deliver new features, we can do it that quickly. A great win that we won with microservices is consumer-driven contracts. So CDC is a specialized test that each microservice should own whenever it's consuming from another one. So whenever a breaking change happens in the provider microservice, the consumer one knows that something has changed and needs to change on him as well. Say, for example, whenever a payload structure change. So some numbers on the property alerts. So as I said before, we do own 3.5 million safe searches, of which generate 130 property matches. So we do have this amount of documented Couchbase. And consequently, we do generate also around roughly 2.7, 2.8 email property alerts per day. What we feel there was one of the key points while developing or while transforming these legacy applications into microservices is that the communications with the operations teams was crucial. So they will help you doing the support, they will help you scaling, upgrading, and monitoring your apps as well. By working closely to the architects, they also help you visualize the bigger picture. So as much as our teams, our devs teams, do own the microservices, architects will keep the applications will keep the applications scalable. They will help all the microservice environment sober, and will keep the separation of the logics or the business logic also separate. Another key point that we felt it was really important is keep it simple, keep it small. So keep your code base as simple as possible, make it code clean, and make your applications as smaller as possible. Just to get into some conclusions. So microservices do allow business logic to be separated, which is great. They allow the deployments and deliveries to be done way quicker than before. Just to give you a comparison on this, whenever a legacy application does get deployed in Rightmove, so there was this two-week time window where the devs used to develop their features, then the branch would take place, then another 3 days of QAing was happening, so in order to understand if there was some regression or if everything was fine, and then we would have a representative of each team, including ops, to help in the deployment process on the next day from 6 a.m. roughly at 9 a.m. So this needed to stop, and now in 25 minutes we can have our features out there. So by having your codes smaller and cleaner, the code maintenance does get easier as well, and the breaking changes they'll get isolated. So whenever something happens, whenever something breaks, you know where to look at, because if everything is really cleanly and separated, if all the business logic is separate, you know where to tackle, and you can actually fix it very quickly. I will pretty much leave you with a phrase that I love from this book, from Simon Newman's. So a microservice should be changed and deployed independently of the rest of the system, which is pretty much what we achieved with this refactor. And I just have to say, thank you.